my sample didn't really do as well as I had hoped. That's the dust fleck on one of them. And yeah, this is a bigger dust fleck on the other. When I saw those, I said, I'm going to have to do this all over again. And then I said, actually, you know what, this time I'm going to ask Professor Smith, is there anything to do to save these? And he said, well, if they're not conductive, they're not a problem, because the main problem with dust is that if it's more conductive, well, if it conducts electricity instead of testing the nanorod's conductivity, you would be testing the conductivity of the dust, which is not really the point. Here are the fingers of the electrodes, and you want them, of course, to stay electrically isolated from each other except for the nanorods in order to test how conductive these guys are. Problem is, when we took a closer look, basically if the dust wasn't touching two of the electrodes, if it had just been like one glob, that wouldn't have been a problem. But we looked at the larger blob, and it went all the way across like that. So then we tried something that unfortunately didn't work, but it was a kind of cool idea. He said, why don't we wait until the cantilever is scanning across here? So these are the gold fingers, this is just the bare silicon. Then let's disable the thing that moves it up and down in the Y direction, so it will just keep going back and forth in this direction. And then let's increase the tapping amplitude, so with any luck, it will start to cut through the dust clump on the sample. So what happened is it ended up with this kind of larger lump here, and a bit of a different shape. Unfortunately, it was still stretching across the electrodes. So at that point we said, okay, and gave up. But he said you should still test the conductivity, because if the sample behaves the way that we would expect a normal, just like clean porphyrin nanorod only sample to conduct things, then it's not a problem, it works fine.